about interest. So let's just make sure we know what some of these common terms mean. What does it mean if I say annually? Yearly. So one time per year. Semi-annually?
Every 2 years? Or twice every year?
Twice every year. Quarterly would be?
4 times per year.
Monthly is?
Monthly. 12.
And daily, this one always gets everyone. How many days are in a year?
365.
Okay, good. All right, so those are the different payment periods we are going to look at. We are finding interest, which can be calculated from formulas. We have done simple interest before, back at the beginning of the year when we did word problems, but most of the time, it's not just simple interest, it's what's called compound interest. That means it's constantly accruing more interest. You don't just pay it once. They calculate interest, add it to your loan amount, and then you have to pay interest on the interest. Okay, so the compound interest formula, A equals P, 1 plus R over N to the NT. I will give you the formula. You just have to know what the variables stand for. So A is your ending amount. Sometimes that's called your future value, what you'll have at some point in the future. P is your current amount or your present value. R is your interest rate. It always has to be in decimal form, not percent. N is the number of times a year we compound. And T, the time has to be measured in years for this to work. The other option, as you accrue interest more and more frequently, I stopped at daily, but is that the most often we could calculate interest? No, we could go every hour, or every minute, or every second. And that leads us into what's called continuous compounding. So if you're compounding continuously, there is actually a button on your calculator. It's above the natural log. It's that E button that we use. So if you hit second ln, it's got that E to the X in blue. And that is just A equals PE to the RT value. A, P, R, and T are the same in both formulas. So this one just doesn't have an N. The only time you use this formula is if we see the word continuous somewhere. So let's try an example. Find the future value of $100 invested at 4% compounded quarterly after a period of 13 quarters. What I have found helps people most is if we write out what our formula is and what our variables are. I'm not mentioning continuous compounding, so we're just doing our regular compound interest. So we need to know what all these variables are. Find the future values. So we don't know our future value, so that's unknown. $100 would be the principal, our present value. 4%, so we have to do it as a decimal, so our rate is 0.04. Compounded quarterly, which is how many times a year? And then 13 quarters. I told you time had to be measured in years. So how would I change 13 quarters into years? How many quarters are in a year?
4.
That would be 3.25 years. So then we plug in what we know. P is 100. 1 plus our R, 0.04, over N, which is 4, to the 4 times 3.25 power. Honestly, it is usually easiest just to try to put all this in your calculator at once, and then you don't have rounding error. So we had 100. plus 0.04 divided by 4 times 3.25 power. And we are talking about money here, so we'll go 2 decimal places, so that's 113.81. So that's what question A asked for, our future value. Part B wants the amount of interest we've earned. How would I calculate my interest?
You just plug 113.81 into your A.
Well, it's actually easier than that.
You use the continuous sum.
We actually don't even have to. How much money did we start with? So we would subtract what we end with minus what we started with. So my interest is $13.81. Is that one okay? Leah must pay a lump sum of $15,000. What would that represent? A. That's what we need to have in the future, not what we have right now. So our A here is 15,000. What amount deposited today? So I'm asking you, how much do we need right now? So we're looking for P. At 4.8%, so the rate would be 0.048. Compounded monthly, so monthly would be 12 times a year. Oh, sorry, I said monthly, but it says annually. Where did I make up monthly? Okay, annually is how many times a year? Okay. We'll give the $15,000 in 42 months. So my time is in months. How do I change it into years? 12, because there's 12 months in a year. So 42 over 12 gives us 3.5 years. Again, we're just doing regular interest. So my ending amount is 15,000 plus P 1 plus 0.048 divided by 1. So 1 times 3.5 power. We have a little simplifying we could do. 1 plus 1.048 divided by 1 is just 1.048. 1 times 3.5 is 3.5. How do we get P by itself? Divide it. So on my calculator, I would just put this all in. So 15,000 divided by 1.048, 3.5 power. So we get $12,729.95. Okay, but let's say she doesn't have that much. She only has 10,000 right now. What interest rate is necessary to get the 15,000 in 4 years? So I'm having you use this formula and solve for different things. So I still need 15,000. But my P is now 10,000. are looking for the R, and we're talking about annual interest rate, so how many times a year are we compounding? Once. And we have 4 years. Summary A is 15,000 equals P 10,000. 1 plus R over N, which is 1, to the 1 times 4 power. Divide my 10,000. How do we solve for R? We need to get rid of the 4th power, so we add a 4th root. Typically with an even root, we would need a plus or minus, but we don't here because an interest rate can't be negative. And then we would subtract our 1. So it's the 4th root of 1.5 minus 1. And we do want to keep a few more decimal places when we do this. So I get 0.1067, or that would be 10.67% interest. So don't just round that one to the nearest whole percent, keep some decimals. Are there questions on that? In general, what's going to happen? The more often you compound, will you get more or less interest? More. The more you compound, the more interest you get. What's the most we can compound? We had yearly, semi-annually, monthly, daily. 365 if we did daily. So out of those, that's the best option. Is there one that's even better? Seconds, which led us into continuous. So continuous compounding is always going to give you the highest interest because the more you do it, the more you're going to get. Okay, I am going to skip the next slide. We're going to go to this one. So find what investing $1,000, an annual rate of 10% compounded continuously for 2.5 years would yield. As soon as I see the word continuous, I know I'm doing A equals PE to the RT power. A is what we are going to have later on, so I don't know that one. P is what we have right now, which is 1,000. Our interest rate is 0.1. Our time is 2.5. So you can just put this in your calculator. So 1,000. You hit second, the LN button, you get the E. 0.1 times 2.5 power. So we get $1,284.03. Any questions on that one? Or how do you guys feel about this in general? Is it going okay? I'd like to do, I know I've got 4 or 5 more. I'm going to kind of jump around. I'd like to do a couple of these at least. And then if you feel good, we can stop early. What annual rate of interest, compounded semi-annually, should you seek if you want to double your investment in 5 years? So which formula were you using?
Continuous one.
Did I say continuous?
No.
So the first one. Okay, we are trying to find the interest rate, so that's our question mark. Now, how many times a year are we compounding? Twice a year. Our time is 5 years. Okay. Did I tell you how much you start with or end with? No. What I did tell you is that you are going to double. So there's different options for how to set this up, but I found it's usually easiest for people just to plug in a number. So let's pick a number. How much money do you want to start with? Any number. There's no wrong answer. $5. If I double it, how much do we end with? $10. So we just made up a starting amount and then doubled it. So now if we plug in, my A is 10, B is 5, 1 plus R over 2, so 2 times 5 power. If we divide with 5, we get 2, so that's where the doubling came in. How do you get rid of a 10th power? Again, we don't need plus or minus because the interest rate can't be negative. Then what do we do? And how do we end?
Multiply.
So we have 2 times this whole thing. So we get 14.35% to double it.
Do we have to make it to the first or percentage?
Typically, that's how it's given. So it would be better to answer it that way. Any questions there? I want you guys to try this one. Invested. So the 2,000 is invested. So is it A or is it P?
No, P.
It's P. It's what we put in. So the P is 2,000. So that means we are looking for A, the ending amount, the future value. The rate is 8.5%, so 0.085. Compounded continuously. Continuously tells me we are doing A equals P e to the RT power. After 2 1/4 years, so what would our time be?
2.25.
A equals 2,000 P to 0.085 times 2.25. How? should get $2,421.52. You didn't get that. Do you know where you went wrong? Do we need more problems? So there is a handout posted on Google Classroom. I want to give you guys time to work on that so that you can maybe not have anything to take home for the week.